Hello, this is the second video for Unit 1. So question 14, we have graph below the image of triangle ABC after a sequence of rigid motions. Are the triangles congruent? And use the properties of rigid motions to explain your answer. All right, so the first thing you want to do is have an idea of what happened, but also make sure that it actually did happen. I've had it in regions before where they put B prime like one away, so it kind of looks the same, but it's not. So make sure whatever it is you think happened actually did happen. So a reflection definitely occurred because B is on the right and now B prime is on the left, so we need to reflect, and then more than likely you have to translate. I always suggest reflecting first, so I'm going to say reflection over the y-axis. Again, I could write the word reflection out. 1, 2, 3, 1, 2, 3. So A is there. We'll go A prime, even though it's not prime yet. B would be there, and C would be right there. Okay, so followed by, or then, whatever you want to say, followed by a translation. I need to move it down, and now I have to figure out how many. And a translation down 3 was my guess by just quickly looking, and it is 1, 2, 3. So B's there, check. A, 1, 2, 3, check. C, 1, 2, 3. Okay, good. So they are congruent. Like I said, always make sure that it actually does work. So use the properties of rigid motions to explain your answer. So we have to answer first. Yes, triangle ABC is congruent to triangle A. Let me try to do that again. A prime, B prime, C prime. A reflection. I'm writing really messy right now. A reflection and translation are rigid motions. So all side lengths and angle measure are preserved. Preserved. I can't fit it. Preserved. There we go. Okay, that would be a really good explanation. You could say, yes, a reflection and translation are rigid motions, so the triangles are congruent. Lots of different things. What you want to make sure you have are those two words in it, even though it seems obvious because it says use properties of rigid motion. Saying it is almost always enough. So all side lengths and angle measures are preserved is the end of question 14. Next one, again, it's the same question pretty much. For this, you want to make sure you're paying attention. So A goes to X. So A ends up where X is. B ends up where Y is. So I can tell that it's a rotation of 180. If you want to check, you can just kind of do this and see that it ends up exactly where it was. So in the diagram below, they're graphed, and they're telling you they are congruent. So they're saying use those properties. So I would say triangle ABC maps to triangle XYZ through a rotation of 180 degrees. If you wanted to be super specific, the center is always assumed to be the origin when you say rotation, but you could say centered at the origin. If it was centered somewhere else, you would have to specify that. Because a rotation is a rigid motion, and now this is going to be the same thing I just did, so I'm just going to say it. So because a rotation is a rigid motion, all side lengths and angle measures are preserved, so the triangles are congruent. So you want to say why the triangles are congruent. It's because it's a rigid motion. Rigid, you want to say that, rigid motion. So side lengths and angle measures are preserved. Question 16 is the same thing. They want you to know this rigid motion stuff. They really, really do. After reflection over the line, this is the image of that. Explain why it's congruent. A reflection is a rigid motion, so side lengths and angle measures are preserved, so the triangles are congruent. Same exact thing. 17, we have two triangles shown. Let triangle A prime, B prime, C prime be the image of this triangle after a rotation about point A. So we're rotating it about point A. That's important to note. Determine and state the location of B prime. Did I just skip a question. No, okay, so we just have two different triangles. Sorry, I was just making sure I didn't miss something. Determine and state the location of B prime if the location of point C prime is 8, -3. So they're telling us where C prime ends up. So 8, -3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. That's where C prime is. Now, I'm going to go, there's actually a shortcut because you know that a rotation is a rigid motion. And see how B is up and then 4. So up and right 4. It's going to still be there like after it rotated. So B is going to kind of like be on top of there. So you can kind of figure it out that way. But the actual method I've taught to do this is rotate 90 to the left still. And I think it said, no, it just said rotation about point A. So you know that you're doing this. Now if it were 90 degrees, you'd know exactly where. C is the key here. So when I rotate it, B should be left 1 from C and up 4 from C. So if I put it back, B is left 1 and up 4. That's how you visually see it. So B prime's location is 7, 1. So B prime is 7, 1. Determine and state, explain your answer. So you can say, because a rotation is a rigid motion, keywords, and then I would continue saying the distance between point B and point C remains the same. A is triangle DEF congruent to triangle A prime, B prime, C prime. Explain your answer. So now I have to pay attention to all of this, and notice it said the prime. So I have to find out where A is as well. Because it was centered at A remains invariant, so that's a quick one to just say, okay, A prime is right there, because that was the center of rotation. But if not, you could do the exact same thing we did. A is left however many from C, so it's still left however many from C prime. So is this triangle congruent to that one? Well, it looks like there's a reflection here. So 1, 2, 3, 4, 5, 6. So 1, 2, 3. That line, as a reminder, is x equals -1 because it crosses through the x-axis at -1. Well, so 1, 2, 3. I know A is good. Okay. B 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so E is good with B prime. And then C, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so they all check. If they hadn't checked, you would say, no, the triangles are not congruent because a reflection does not map all the triangles onto each other, and a reflection is a rigid motion, blah, 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 blah. Now, because it is, you're going to say, yes, they are congruent because triangle A prime, B prime, C prime can be mapped onto triangle DEF by a reflection over x equals -1. Now, some of you might not have thought of that. You might have reflected over the y-axis and then translated left. That's still fine. You would just have to specify all of the things you did. Because a reflection is a rigid motion, and then it's that same sentence again. Because a reflection is a rigid motion, the triangles are congruent, side and angle measures are preserved. Those are the key ones. Moving on to question 1. 2 right triangles must be congruent if. So now they're talking about congruence criteria. So let's just quickly write, there's 3 of them up there. Don't forget there's HL and there's also angle, angle, side. So that's what our main focus is in these questions. 2 triangles, right triangles. So I'm going to draw a right triangle. I'm going to draw another right triangle. Okay. And I want them to be congruent, so I made them roughly the same size. I'm looking for one of these. I already have an angle right now, but I don't know if that angle is going to be one of these or if that angle is going to be HL until I go through all of the options. An acute angle in each triangle is congruent. So if I get that, I have angle, angle, and that is not a method of proof. Angle, angle, and angle, side, side are not methods of proof. So one is out. Okay, the lengths of the hypotenuse are equal. So now I have a side or a hypotenuse, but I have nothing else. So that one is out. The corresponding legs are congruent. So I erase my hypotenuse really quick. There's the corresponding legs, plural. So that leg and that leg and that leg and that leg. Well, now I have side angle side, so there's the correct choice. The areas being equal don't prove congruence because you have, right, it's not one of the SSS, SAS, all that kind of stuff. So areas can be the same and the shapes can be different. That happens all the time. Which statement is sufficient evidence that these two triangles are congruent? So again, anytime it asks this, it's looking for SSS, SAS, all that stuff. So in number 1, first of all, I don't have any vertical angles or reflexive property. So I already know number 1 won't have enough information because there's only 2 things and I know that I need 3. Number 2, I can eliminate quickly because it's angle, angle, angle. A proves similarity. It does not prove congruence. So now I'm left with 3 and 4, and they're minutely different. The correct answer is 3, and I'll tell you why. Because they both seem the same. Number 4 seems like it's going to be angle, side, angle, or angle, angle, side. I don't remember which. But number 3 is side, side, side. The reason it's 3 and not 4 is the following. 3 gives you side, side, side. 4 gives you point, side, angle. Point is never a part of it. A point is like this and like this. I could draw my angle this way from that point, and I could draw my angle that way from a point. A point does nothing. It's like this little sneaky thing they put in there. But that's why it's 3. It's because it's side, side, side. Okay. In the diagram below, which is on the next page for us, again, I don't know why it printed like this, but those should be up there, don't forget. Segment AC is congruent to segment DF. Points AC, D, and F are collinear. So it's already marked for us. And D prime, E prime, F prime will be the image after a translation along L such that point D is mapped to point A. So it's telling us that this triangle is going to slide over here. And it's now like that. Okay. Such that point D is mapped onto point A. Determine and state the location of F prime. Explain your answer. So if D ended up at A, F is now at C. So F prime mapped to point C, and then you would say that same sentence. Because a translation is a rigid motion, side measure is preserved. And that's why, because A to C is the same as D to F. Okay. Continuing with the same question, let D double prime, E double prime, F double prime be the image of D prime, E prime, F prime after a reflection across line L. So now we're here. This was E prime, D prime, F prime. Now they're reflecting over this line. So this is getting folded over. Suppose that E double prime is located at B. Are they congruent? So E double prime ends up here. Yes, they are congruent because, so we have this side here. It mapped and stayed where it was because it's on line L. EF and ED, because of E mapping there, that means that both of those side lengths are preserved and they map perfectly onto each other. So again, they just want to hear it. A reflection is a rigid motion, or so, yes. A reflection is a rigid motion, therefore side lengths and angle measures are preserved. They just want that same sentence again. Remember that sentence. Triangle XYZ is shown below using a compass. My voice is trailing because I'm grabbing mine. Using a compass and straight edge on the line, construct and label triangle A prime, B prime, C, or excuse me, ABC, such that they are congruent. Based on your construction, state the theorem. So state the theorem, it means SSS, SAS, all that stuff. So I just need, remember, anytime I copy, I need a space to copy to. So I'm going to start right there. And I'll copy XY first. Okay. So XY, now I have to pay attention to this. This is going to be my A because I started at X. So now that I copied this, I know that this is B. So there's B. Now I need to figure out where Z, which will be my C, is. So to do that, I'll measure from X to Z. Copy that arc. Then I'll measure from Y to Z. Right there. Notice that I'm placing my compass at B now because I was just at Y. I'm off. I gotta move it. Okay, so if that happens to you, just go back. Oops. And extend. So they're meeting off my paper right now. If that happened, well, first of all, you would have had more space on the exam itself. So I'm just going to redo it over here really quick just so that you can see the proper construction. So here's A. Again, I already told you I would copy X, Y. But I was going to say, if that happens to you, just extend your arcs and they will eventually cross. But if they don't, if they go off the paper, you're going to have to do what I'm doing, and you're going to have to redo it. So it's B. And now I need X to Z, which is my A. And then Y to Z, which is my B. And see how they cross? There it is. There's C prime. Use my straight edge to connect it. And as far as theorem goes, I just copied 3 congruent sides, so my theorem is side, side, side. That's the theorem I used to construct, knowing that all sides are congruent. Oh, there was a line. Well, obviously this would have been on one page together on the exam itself. So that's it for Unit 1. Hopefully you found this helpful. Have a great day.